So in this video, we're going to focus on a specific part of the quadratic formula called the discriminant, and we're going to use it to determine how many solutions a quadratic function has, as well as what type of solutions that quadratic function will have. So before we can use the discriminant to make predictions, we need to talk about what the discriminant is. And the discriminant is this portion underneath the square root. So when we're referring to the discriminant value, we're referring to the part that's represented by b squared minus 4ac. So this portion is called the discriminant, and it can be used to determine how many solutions a quadratic function has, and then if those solutions will be real or imaginary. Now remember, when we're finding solutions to that quadratic function, we're setting that equal to 0. So it looks something like this, where a, b, and c have values, and it's set equal to 0. And remember, when that's set equal to 0, we're finding x-intercepts. So when we're trying to determine how many solutions we're going to have, the discriminant is talking about how many x-intercepts a function or a quadratic function could possibly have. So we have three different scenarios that are going to take place. One is that our parabola is going to come through, and it's going to hit the x-axis at two very clear and obvious points. So when it comes through and it hits the x-axis at two clear and obvious points, we can see that we have two x-intercepts, and we therefore have two real solutions. Then the second situation that we can have is we can actually have a parabola that comes down, touches the x-axis in one single spot, and then shoots back up. And in this case, when we only touch the x-axis in one spot, we have one x-intercept, or we have one real solution. And then the third situation we're going to see is we're going to see something like this, where the parabola comes down, and it never actually touches this x-axis. So here, we don't actually have x-intercepts, and while I know you're tempted to say that there's no solution here, there are actually solutions here, they're just not real. So when we don't cross the x-axis and we don't have any x-intercepts, what's really happening with our quadratic function is that it doesn't have two real solutions, but it instead has two imaginary solutions. And so in this case, we're going to have the imaginary I involved in our answers. So our options are that we have two real solutions, one real solution, or two imaginary solutions. So what we're going to do here in a couple of examples is we're going to look at what happens in the discriminant and then use it to pick up on some patterns about how the discriminant can help us to figure out, do we have two real solutions, one real solution, or two imaginary solutions. So here we can see our quadratic is all ready to go, and I have an a value of 1, a b value of 6, and a c value of 9. So we're going to utilize our quadratic formula here and pay close attention to this discriminant value and what happens. So if we use the quadratic formula, we have x equals negative or opposite b, so that's negative 6, plus or minus the square root of 6 squared minus 4 times 1 times 9. All divided by 2 times 1. So just like before, I'm going to focus on this piece underneath the square root here, which I know is called the discriminant. So if I focus on this, I have 6 squared minus 4 times 1 times 9. Now I'm going to use keep change there so I don't make an error. And this becomes 36 plus, well, negative 4 times 1 is negative 4. Negative 4 times 9 is negative 36, so this becomes 0. So what I really have here is x is equal to negative 6 plus or minus the square root of 0, all divided by 2. So what I notice here is that my discriminant is 0. So that's what I found out as I went through and solved this. Now, if we finish this up to see how many solutions and what type of solutions we get, here this is plus or minus 0, so I have negative 6 plus 0 divided by 2. Well, that becomes negative 6 over 2, which is negative 3. And then my other option is negative 6 minus 0 over 2, which is negative 6 over 2. which is negative 3. So what I'm seeing here is I have the same answer, and it's a real number. So when you have a discriminant that is 0, you're going to get one real solution. So let's look at a second example here and see what happens with this discriminant. So here we have an a value of 1, a b value of 5, and a c value of 6. So if we start off with our quadratic formula, we have x equals negative b, so that's negative 5, plus or minus the square root of b squared, so that's 5 squared, minus 4 times 1 times 6, all divided by 2 times 1. So here we're going to start off by being focused on our discriminant, or that piece underneath the square root. So we have 5 squared minus 4 times 1 times 6. And again, I'm going to use keep change here so I don't make an error. So this becomes 25 plus negative 4 times 1 is negative 4. Negative 4 times 6 is negative 24. So that becomes 1. So here we have a discriminant of 1. So let's keep that as a note. So then if I keep going here, I have x is equal to negative 5 plus or minus the square root of 1, all divided by 2. Well, I know that the square root of 1 is just 1, so this is really x equals negative 5 plus or minus 1 divided by 2. So then from here, if I split this up, I have negative 5 plus 1 divided by 2, so that's negative 4 over 2, which is negative 2. And then I have negative 5 minus 1 over 2, which is negative 6 over 2, which is negative 3. So what I'm noticing here is that with a discriminant of 1, or a discriminant that is a positive value, I end up with 2 real solutions. So let's take a look at one more example here. So here we have an a value that's equal to 2, a b value equal to 3, and a c value that is equal to 5. So if we start off with the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So I've substituted all of my values in there, and then I'm going to focus here on the discriminant. So I have 3 squared minus 4 times 2 times 5. Use keep change there. I get 9 plus, well, negative 4 times 2 is negative 8. Negative 8 times 5 is negative 40. So that becomes a negative 31. So I can see that my discriminant this time is a negative value instead. So if I go and replace that into my equation, I have x equals negative 3 plus or minus the square root of a negative 31 all over 4. Well, because I have a negative 31 in there, I know I want to simplify that so it doesn't have a negative. So I would do the square root of negative 1, the square root of 31. So this one becomes x equals negative 3 plus or minus I times the square root of 31 all over 4. Now from here, we can split this up into 2. We can say x equals negative 3 plus I square root of 31 over 4. That's one answer. And the second answer is negative 3 minus I square root of 31 over 4. But what I notice here is that because I have an I in there, I really can't simplify this further. And because I have an I in there, I know that I have 2 imaginary roots. So we've seen all 3 situations here. We've seen 1 real root, 2 real roots, and 2 imaginary roots. So we're going to tie this all together on the next slide. So what's really cool about the discriminant is we can actually use it to make predictions about the types of solutions that we're going to see. So what we saw happen is we saw the discriminant was positive, 0, or negative. And if the discriminant is positive, what we saw happen is that we have 2 real solutions. So this is where we get 2 solutions that do not contain the imaginary I. And then when the discriminant was 0, we had 1 real solution. So So this is where we had something that was a repeated answer, that we only had one unique answer, but it was real. It did not contain the imaginary I. And then if the discriminant was negative, we ended up with two imaginary solutions. So both of these solutions contained the imaginary I. So depending on what happens with the discriminant, if it's positive, you know you're going to have two real solutions. If it's 0, you're going to have one real solution. And if it's negative, you're going to have two imaginary solutions. So let's use this new knowledge now to determine how many solutions an equation will have and what type of solution that equation will have. So here we can see in this first example that this is all ready to go with the discriminant. So remember, we're just determining how many solutions and what type of solution something is going to have. So if we're just determining how many solutions and what type, we're going to utilize just the discriminant, which remember is b squared minus 4ac. So it's the part underneath the square root that we're going to focus on. So here we can see that a is equal to 3, b is equal to 4, and c is equal to 3. So here we have b squared, so that's 4 squared, minus 4 times my a value of 3 times my c value of 3. So here if I simplify this, I'm going to start by utilizing keep, change, change. I then get 16 plus, well, 4 times, or negative 4 times 3 is negative 12. Negative 12 times 3 more is a negative 36. So I know that I'm ending up with a negative number underneath that square root, and I have a negative discriminant. So if I have a negative discriminant value, remember, this is telling me that I'm going to have a negative underneath the square root, which means we're going to have two imaginary roots that contain that imaginary I. All right, looking at the second example here, we need to start by rewriting this because it's not quite ready to be solved. We have to have everything on one side and it equal to 0 in order to utilize the discriminant. So we start by adding that 8x to each side, and then we can again focus in on the b squared minus 4ac because we are just looking for how many solutions we're going to have and what type. So here I can see that my a value is 2, my b value is 8, and my c value is 8. So here we have 8 squared minus 4 times 2 times 8. And then I'm going to utilize keep, change, change here. So I have 64 plus, well, negative 4 times 2 is negative 8. Negative 8 times 8 is negative 64. So I add those two together and I get a discriminant value of 0. So because I have a 0 underneath my square root in my quadratic formula, I can determine that I have one real solution. Because I know when the discriminant is 0, I'm going to have that repeated answer appear twice. So that means I only have one real solution.